Hello everybody, myself Dr. Kode Jaya Prakash, working as Senior Assistant Professor in Department of Mechanical Engineering at VNR VJEC. So now today I am going to discuss about this part orientation and support structures. So what is the key important role for the part orientation and what are the importance of support structures? So that we are going to see for additive manufacturing. So how these two plays an important role for the metal or additive manufacturing or polymer additive manufacturing or liquid based additive manufacturing. So now when you're going to go for this additive manufacturing, first we need to work out on the error-free CAD model. So how well you are going to prepare the CAD model? The first and foremost thing which we should be able to keep in mind is that lattice generation. So means that lattice structures, the CAD model should be worked with the lattice structures. So if you are going to work out with the lattice structures, we can able to work out on the reduction of the weight and to provide more strength of the object, and also less material is going to be utilized. And after generating of the lattice, then we need to talk about the lattice analysis. So how well your lattice generation is going to be done, and how we are going to validate your structures whatever you are going to generate it. So these structures are going to be evaluated by using several FEA software, whereas this mesh and the two complicated complex profiles is going to be the entirely is going to be mesh, and this CAD package is going to apply the simulation and with the help of the beam elements and the mass elements and 2D shells model. So to analyze the entire lattice model whatever we had done. And coming to the case of after doing this lattice analysis, next we need to think about the tray configuration. Means that if you want to print the model, how well it is going to fit in your 3D printer. Can you able to print the multiple models, or single part is going to be required, or if there is a required to split the models and later to perform the assembly, etc. So this sort of tray configuration analysis which has to be done completely. Next important thing is the topology optimization. So the main topology optimization is that especially to reduce the weight and to provide more strength. So as much as possible for the metal additive manufacturing, this topology optimization is a must and should thing which we are supposed to be performed. Because here we are going to define your loads and boundary conditions and design constraints, and it is going to optimizes your mass and shape. So it automatically works out the best performance which is going to be given to complete the model. Right? And coming to the case of engineering content. So engineering content means that we should able to, with the solid modeling, we should able to calculate the masses, and we need to, suppose if you're going to go for assembly, we need to work out on the fits and clearances and tolerances, etc. And later on to export in the files for the 3D printing. So these are the points should be keep in mind, especially when you're going to do with the CAD model for the additive manufacturing, not just like simply doing CAD model, doing assembly, etc. It's not required. So for how well you are going to prepare the CAD model for AM. One is lattice generation, lattice analysis, tray configuration, and followed by topology optimization. These are the essential points which we should keep in mind to generate a CAD model. So as soon as how this CAD model means that what is the role of this CAD model is that realism means that whatever the model we are going to generate it. So this CAD models is going to be shown in the form of a realistic models, so as you can able to visualize clearly while doing the modeling. And also the CAD model which are going to use, the CAD software which are going to use should be a usable, and a user interface should be completely flexible so as to understand and so as to use the different sort of features, etc. to work out or reworking of the complex geometries. And followed by the accuracy. So the tolerances are expected for the design, and these calculations are how much your calculations are precise and how accurate you are going to go for the parts. So means that these are the key important points. One is tolerance optimization, and other one is a maintenance. Maintaining the resolution, resizing of the holes and watertight geometry, and minimizing the use of support metal, balancing part density and the strength. So these are the essential points you should keep in mind to prepare a CAD model for the additive manufacturing. It's a brief summary of the points. So next, part orientation. So what is a part orientation? How this part orientation plays an important role for the additive manufacturing. You can see this part orientation is going to depends upon this support generation also. It depends upon the part orientation. So if the angle is more than within 45 degrees angle, no support materials are required. If it is going to exceed more than 45 degrees, then support structures are obviously it is required. So we need to optimize the supports. So this optimization of the supports and what sort of accuracy we are going to make it is going to be completely dependent upon this part orientation. As you can see that part accuracy, you can see some simple example. If you take the case of this part accuracy, if you're going to lay up this additive manufacturing for these two cylinders, one is vertical cylinder, one is horizontal cylinder. So this vertical cylinder is going to lay up the metal is going to lay up the metal layer by layer, and obviously it takes more time. But whereas this horizontal cylinder, that laying up of the layers will take less time, and also you can see the small support is also generated here, but this finishing of the support requires more time. And you can see this accuracy is going to be affected in this orientation. But whereas in this orientation, this vertical orientation, you can't see this any sort of support metal is required, etc. Any sort of lump is also not required to print the part. You can see when you compare with the two orientations, and this vertical orientation gives a much amount of accuracy. So it depends upon the accuracy and depends upon the type of functional model which you are going to do. Based upon that, we need to select this part orientation. So obviously, if you are going to look for the accuracy point of view, then always, as per the thumb rule, always we should orientation the parts vertically. Better to orientation the parts vertically. Suppose if it is a demo models or some sort of just models, there's models we are going to show, conceptual models which are supposed to show. You can this orientation not plays an important role. We can lay either as a horizontal orientation also. But you are going to look for accuracy point of view, always orient the parts vertically. As you can see, this build time is also depends upon the part orientation, because based upon the orientation, the layers are going to depend upon. So these layers are going to place an important role, especially to lay up the material, and time is also going to be fixed. And part strength. So generally, so if you take the case of fused deposition melting, for functional parts, it is always important to consider the application of direction of the loads. So where you are going to apply the loads. For example, FDM parts are mostly likely to delaminate and fracture when placed in tension in the Z direction compared to the XY. So means that Z, because always you need to see that direction of the loads, and then so based upon that we need to do for the orientation to print the parts. And coming to the case of support structure, support materials are going to add extra time, and also it is going to increase the cost of the print. But without supports, we can't print the part, because supports itself act as the foundation of the part. A simple example is that if you take the case of a building, without the help of pillars or beams, etc., you can't lay up. The building can't withstand, just like that. So supports are going to fetch the model, so that it is going to act as the pillars for the parts to be printed. So at the same time, supports, if you are going to remove the supports completely, the part is going to collapse it. So in this case, we need to optimize the supports. And so as this optimization is going to fetch you important time, so that we can able to perform a finish later on while removing of the supports. So this plays an important role for the part orientation to optimize the supports. And you can see this part orientation by supports. So what are the different sort of additive manufacturing techniques which requires part orientation plays an important. FDM, it is very important, fused deposition melting or metal extrusion. And for SLA or DLP, which is very, very important for the part orientation. And SLS, selective laser sintering, also very important. And followed by metal jetting is also quite important in the place of case of part orientation. But whereas binder jetting, it's a powder based, so because unbinded powder can access the supports. So in these cases, so this part orientation doesn't play much important role. But whereas if you go for metal 3D printing like DMLS, direct metal laser sintering, and selective laser melting, so this part orientation is very, very important. So I discussed you about the rules of thumb. Always orient cylindrical features vertically for the smoother surface finish, and we need to consider the direction of loading while choosing the part orientation. And this part orientation is quite important for polymer as well as for metal and DLP or SLP. So what is the purpose of part orientation? Means why we are going to choose this part orientation is a finding. So the shortest build time, that is a minimizing the number of layers, and also to find the minimal amount of supports and easy access of the supports. So easy access of the supports can be able to remove the supports very easily, and the best possible surface roughness and to minimize the staircase effect. And also for a metal sort of things, we can able to minimize the level of residual stresses which leads up to part distortion. So this is the purpose of part orientation. And coming to the case of support structures, so because support structures are especially required for the parts which are subjected to overhangs. For overhanging portions, the supports are obviously is required. So support structures also can able to act as heat dissipators, whereas high temperatures are involved in case of metal 3D printing. So it is they are going to absorb the heat and going to regulate and maintain the temperature, and also those supports are also useful to withstand the part till the part is going to be completely printed. What is the purpose of support structures? So supports the part in the case of overhangs, strengthen and fix the part on the build platform, and is going to conduct the excess heat away, and is going to prevent warping or complete build failure. This warping is a common defect for is going to be seen in the FDM, because not properly maintain the temperature, especially for the longer prints. For the longer prints means that 14 hours, 15 hours or 18 hours of print, we should maintain the proper glues, and we should maintain the proper bed temperature, and we should rework on the supports. What is the type of model and type of orientation and type of supports you are going to use, and all this plays an important role to reduce the warping issue. So you can see the support materials. You can see this for my metal 3D printing. The supports obviously looks like a lattice structures, and this is the supports for the polymer printing. And for polymer, you can see the support. This complexity because these overhangs are going to be subject to the supports. For FDM process or for SLA process, we can see about that. We are going to use the different tools. You can able to remove the supports. So that I can say that this is a breakaway supports. We can able to use the different tools so the comfortable we can able to remove the supports. But whereas for the metals, removal of the supports is not that much easy. So these supports are going to be seen like a lattice structures, where we are going to use a set of machines like a band saw. We are going to use the wire EDM, and we are going to use the different tools to remove the supports for the metal 3D printed parts. It's not just like easy like FDM printable parts or SLA parts to be printed. We can see the what are the standard techniques and where support structures are required. When you take the case of SLA, so this support structures are obviously it is required to optimize the supports. And for material jetting, so for this powder-based process, the support structures are much more important. And fused deposition modeling, obviously it is required. And selective layer sintering, because since it's a powder-based, the adjacent powder which is not sintered, itself acts as supports. So no additional supports are required to work out for the SLS. And if you take the case of binder jetting also, it's not required, because binder jetting and SLS selective layer sintering both comes under the powder based. So for a powder based process, support structures are obviously not required. The unsintered powder or unbinded powder itself acts as supports. But whereas if you go for metal 3D printed parts like selective laser melting and DMLS and DAD process and electron beam melting, support structures is very, very important to work out for the optimized part. So you can see this so how well it is important for SLM and DMLS and EBM. So how the DAD is going to be used here and how what sort of the design. So we need to work out for the design considerations to work out our optimization of the supports for DMLS or EBM or the DAD process. Right? And what are the downsides of the supports? So means that supports are required, but if much amount of supports are there means, then what are the issues that are going to happen? One is metal cost, because support generation will obviously require additional material during the printable process, which is also calculated as per the printing time. And limited geometrical freedom, because while removing the supports manually or hand or tools especially, because this is going to restrict to certain geometries which will affect the accuracy point of view. Extra time, because extra time is also required for the to accommodate support materials, and also while removing and post processing also it takes more time. And a risk of damage. If sometimes supports are not, if they are not easy to access, means that sometimes while in the process of removing, there is a chance of damage of the part. So next, what are the four ways? What are the best 4 ways to remove the support structures? One is, I told you, choose the best optimal orientation to optimize the supports. So this will reduce the supports, and this you can able to plan in the easy access of the supports, and you can able to work out for the best optimal orientation. Second thing is optimize your support materials, because we need to see supports are required, but wherever it is not required, you can able to work out in the different softwares, different open source softwares, because in the unnecessary portions, if you are going to keep the supports, means that it will add the extra cost. So this optimization of supports as well as part orientation plays an important role for the make the parts to be good. And it's a better thing always while using the CAD models, better always use the fillets and chamfers. So this using of fillets and chamfers can be an alternative solution to reduce the support materials. And also split. So suppose if the parts are too big, it's always better to split your part, so that we can able to reduce the supports. So these are the important things we should keep in mind for part orientation and support materials for additive manufacturing. So thank you for listening my session. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.